Okay, we're going to go ahead and start actually graphing log function. So this is the end of the 6.4 notes and actually the end of this unit. So we already briefly mentioned that logs are the inverses of exponentials, right? That's why we convert between the two. That's what we practiced last time. So these are inverses. Very important to remember that because we talked about a set of 3 points if you are exponential. If you're exponential, I asked for 3 points for you to memorize. It was 0, 1, 1a, -1, 1 over a. Those were the 3 points. Well, because these are inverses, that means the domain and the range switch. So that means for the log, the 3 points that you have to memorize are the same as the exponentials, but the x and the y switch. So instead of 0, 1, it's 1, 0. Instead of 1a, it's a1. And instead of -1, 1a, it's 1a, -1. So you need to have both of these memorized because you're going to be asked to graph both types, both logs and exponentials. So you need to have them memorized. So this one also will have an asymptote, except it's going to be vertical. So maybe I'm going to put this over here. The log ones have a vertical asymptote. So it'll be like x equals a number, where your exponentials are going to have a horizontal one, and those were like y equals a number. So a lot of similarities between the two. So if you could graph an exponential, you will be able to graph a log. So we're going to go ahead and just graph one of these right now because these are really kind of the same thing. So we're going to graph both the exponential and the log. So let's go ahead and start with the exponential. So again, you should have the 3 points memorized that you need to be able to graph. 0, 1, 1a. And remember, in this case, a is 2. So it's 1, 2, -1, 1/2. For our log ones, well, actually, let's just go ahead and graph all of that. So I'm going to make dashes 1, 2, 3. I'm going to graph those points in blue, 0, 1. Remember, it looks like a J, as long as there's no rotations or anything like that, which it does. It looks like a J, and then there is my asymptote. So that is my exponential, right? Y equals 2 to the x. Now, if we do the log one, we're going to go ahead and graph its table. So we've got x, y. The points that you're going to memorize are 1, 0, a1. The a is this number right here. That's your a. So a is 2. It's whatever the base is. So we're going to have 2, 1, and then it's 1 over a. So 1 over 2, -1. Or you can literally think it's the opposite of these right here, right? So we flipped all the x's and y's. So if I go ahead and I graph this, 1, 0, 2, 1, 1/2, -1. So it looks like this, and it has an asymptote at y equals 0. So you should notice, because we've talked about when you have an inverse, that it reflects on the y equals x line. So notice that it does. There's its mirror image. This is y equals x, and it reflects over it. So when you go to fill things out, let's start with the domain of the exponential, y equals 2 to the x. The domain is left to right, so this one is -infinity to infinity. If you look at the graph, lowest to highest is 0 to infinity. X-intercept, it does not have one. So this is the blue one, it does not cross. The y-intercept, it does cross at 0, 1, and the asymptote, because it is horizontal, is hoi, so it's y equals 0. Now, if we go ahead and we take a look at now the log function, so the red one, lowest to highest, or not lowest to highest, left to right, sorry, domain left to right. So it's 0 to infinity, Range is lowest to highest. That one is negative infinity to infinity. X-intercept, it does cross the x-axis right there at 1, 0. It does not cross the y-axis, so this is none. And the asymptote is vertical, vux, 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 so it's x equals 0. So what is the relationship that you see between them? That's what the next question's asking, between the graphs, domain and range, intercepts, and asymptotes of the inverse functions. What conclusions can you make? Well, first, if you look at their domain and range, they flip. So the domain and ranges flip. Same with the x-intercepts and the y-intercepts. Now, obviously, you have to change where the x and the y is, because an x-intercept has a number for the x and the y-intercept has a number for the y. And same thing with the asymptotes. So asymptotes go from vertical or horizontal, whichever way you want to think of it, horizontal asymptote to vertical asymptote. And there's one more thing, is that you can notice, obviously, that it reflects over y equals x. So if we did that again, it would have looked very similar to part A. So we're going to go ahead and do a few examples together. So given this problem, we've got log base 3 and of x plus 1. So first of all, just like we've always learned with translations, what happens to the inside affects your x. What happens to the outside is going to affect your y. So if we take a look at the x plus 1, this is inside. So when we go to graph this, this means left 1. So keep that in mind. So up to you if you want to find the domain or if you want to graph first. We talked about the domain. You're going to look specifically inside right here in the log, and you set it greater than 0. So we're going to go ahead and say, oops, x plus 1 is greater than 0. So that means x is greater than negative 1. So that's our domain. You can write it as an inequality or as an interval. So we're going to go ahead and graph it. So if we're going to go ahead and graph this, very important. And we're going to actually skip the F. We're just going to graph F on the graph below, okay? Because otherwise it gets a little bit messy. So we're just going to graph F. So in order to graph F, we're going to go ahead and make our table for our core graph. Our core graph is y equals log, and it was base 3. So A is 3. So remember your 3 points, 1, 0, and then it's A1, A is 3, so 3, 1, and then it's 1 over A, so 1 over 3, negative 1. So again, A is this base right here. And I'm going to go ahead and make 4 dashes. We're going to go ahead and graph this. These graphs are really small. That's why we're just going to graph the original function. We're not going to worry about graphing the inverse. So we've got 1, 0, 3, 1, 1/3, negative 1. So it looks like this. Kind of like an R. I remember my students used to say it looks like an R. And whenever you have a graph like this, it's always going to have a vertical asymptote, vux, vertical. So that would be the original one. But don't forget, if you go all the way back to the top, remember I wrote a note that said that it's going to go left 1. So now I have to go back and move all of my points left 1 for my final answer. So I'm going to go back. Remember, I've got to go left 1. So I'm going to move this point left 1, this point left 1, and this point left 1. So it's going to look like this. And my asymptote is also going to go left 1. So now it's located at -1, which makes sense because if you look at the domain says from -1 until infinity. So left to right, that makes sense that my asymptote changes. And if you have a lot going on your graph, a lot of times it's helpful just to kind of highlight your answer. So part C says find the range and any asymptotes of f. So the range, lowest to highest, it's always going to be -infinity to infinity. The asymptote, Buck's vertical, this is going to be x equals -1 because it went left 1. And next it says find the inverse. So we're going to find the inverse, but we're just not going to graph it, okay? So how do we find an inverse? If we're going to find the inverse, remember the 3 steps whenever you're finding an inverse is you're going to go ahead and remember you have to flip x and y and then solve for y. Or if you don't want to think about it as flipping, you can go ahead and say switch. Maybe I'll use that word. I like that better. Switch x and y. So my original equation is y equals. So now I'm going to turn that into x equals. And then it's log base 3 of, it says x plus 1. So I'm going to make that y plus 1. So I have to go ahead and switch it. Okay. The inverse, remember, is an exponential. So I have to take the log and turn it into an exponential. The base is 3, the exponent is x, and it equals y plus 1. Again, the goal is to solve for y. So you have to subtract 1 to get y alone. You cannot actually subtract 3 to the x minus 1. Those are not like terms. That just becomes 3 to the x minus 1 equals y. So that's your inverse function right there. Make sure that -1 does not look like it's attached to the exponent x. It's a solid full number right there. Find the domain and range. Well, the domain and range is easy. You've already found that information out because if you recall, inverses, the domain and the ranges flip. So if this is the domain of the original one, its inverse is the range here. So this is going to be -1 comma infinity. And then same thing, if we know what the range is, then we know the domain of the inverse. Done. Again, we are not going to worry about graphing the actual inverse. So that's good. We got enough going on our graph. All right, let's take a look at the second example here. So we're going to practice one within natural log. So that's good to practice. Again, remember E is about 2.71, and you can get that on your calculator. So find the domain. Remember that for the domain, you're going to set this part greater than 0, not x plus 1, just the x. If they wanted the x plus 1 to be greater than 0, they would use parentheses. So it's just x is greater than 0. So that is from 0 until infinity. That is done. Now let's go ahead and graph it below. So I'm going to go all the way down. Remember, our core graph, or maybe I'll write the whole thing just because you have to zoom all the way up to the top. So the original equation is y equals natural log x plus 1. So the core is just y equals natural log x. Remember, there's an imaginary e here. So if we go ahead and we graph our x and our y, those 3 points that I've asked you to memorize here is 1, 0, a 1, a is e, so that's 2.71 comma 1. 1 over a, 1 over e, you can type that in your calculator, is 0.37, -1. So we're going to graph that, and then we have to go left 1. So I am going to make 3 dashes. And again, it should look kind of like an R. So 1 comma 0, 2.71 comma R, -1 point, I'm sorry, 0.37, -1. And so it looks kind of like in lowercase r when I say r, obviously. And that would be the asymptote, except again, because of the +1 here, I'm going to have to go ahead and move everything up 1 because it's outside of the function. When you move the asymptote up 1, that's not going to change it. It is still going to be located at x equals 0. Everything else can move up 1. Oops. It's going to look like that, and it does not cross that asymptote there. So if we go ahead and start to answer some of the questions here, and I'm actually going to highlight my final answer here. So there's my asymptote and there's my graph. Notice how you can see my points. I should always be able to see your 3 points. So the range is going to be lowest to highest. So that's going to be -infinity until infinity. The asymptote, vertical, it's x equals 0. It did not move. And now it says find the inverse. So now I have to go back to the equation. And remember, you're going to switch x and y and solve for y. So let's go ahead and say x equals natural log y plus 1. So we switched the x and y, and now we're going to solve for y. So the first thing we have to do is subtract 1 to both sides. So it's going to be x minus 1 equals natural log y. Now we have to convert it. Again, this isn't a little e down here. So this is going to say e to the y, e to the x minus 1 equals y. There we go. And now y is by itself. So e to the x minus 1. And that's my answer there. Now find the domain and range. Again, these are just partnering up. If you know the domain of the original function, then its inverse, the exponential one there, is going to be this range. And then if you know the range of the original one, you know the domain of the inverse. So this is going to be -infinity until infinity. And those match up. And that's it. Okay, let's go ahead and we're going to do one more example. And then we'll do kind of just a writing one. So we're not going to do example 4. That's actually an exponential one. Notice how you'd have to be careful here. This is exponential, so you'd have to make sure you use the correct points because you are going to have to be able to graph both exponential and logs, right? So last section was exponential. This one is logs. So I'm just going to keep practicing the logs. So first one, find the domain. I'm going to actually say stop, and I want you to go ahead and find the domain. All right, welcome back. Let's take a look at the domain. Domain should be pretty easy. All you have to do is set this inside part here greater than 0. So x minus 3 is greater than 0. So x is greater than 3. So my domain is from 3 until infinity. And then we're going to go ahead and graph this. So I'm going to go ahead and recopy this equation. And again, we're not going to graph the inverse, so you can cross that part -1 off. So the equation, the original one is y equals negative log base 2 of x minus 3. And it's okay if you write into the next one because, again, we're not doing that problem. So that's the original one, right? So you've got a couple of things going on here. First, notice you have a reflection here. So because of that negative sign in the front, you're going to flip over the x-axis. And because this -3 is inside the function, that means you're going to go right 3. So a couple of things to be aware of. So let's go ahead and make our table x, y. The 3 points that I asked you to go ahead and memorize is 1, 0. a comma 1. A in this case is going to be 2, right? It's whatever your base is. So this is 2 comma 1. Then it's 1 over a, so 1 over 2, negative 1. That is our original core graph for this problem, because again, our core graph is just y equals log base 2 of x. So for this one, I'm going to go ahead and make 4 dashes I need. I'm going to graph my original core function. 1 comma 0, 2 comma 1, and 1/2 negative 1. So again, looks like an R. My original asymptote is right through here. But now I've got to do all that fancy stuff that we've got going on. So flip over the x-axis here. So I'm going to go ahead and flip over the x-axis. This is your x-axis. So this point would stay. This point would come down here. And this point would come up here. So it no longer is going to look like a R, because now we flipped it. And we have to move every point right 3. So it looked like this. The asymptote, when you flip it over the x-axis, doesn't do anything. So the next thing now is we're going to go ahead and move every point right 3. 1, 2, 3, 1, 2, 3. And then we've got, so that's actually at a 5th. That's at 5. I don't plot that many points. And this one's over 1, 2, 3. And it's helpful when we have grid lines, which you will on your test. So it's going to look like that. And then think about your asymptote. If you're moving right 3, your asymptote should also move right 3. So I'm going to have to redo that part. 1, 2, 3. There's my asymptote right 3 now. So it goes through the 3. And then there's the rest of my graph. I just want to make sure it doesn't look like it crosses my asymptote. So again, because I've got a lot of graphs going on, I'm going to go ahead and highlight my final answer. Okay, so let's take a look at answering the questions now. So it says find the range at any asymptote. So the range lowest to highest is -infinity to infinity. The asymptote has now moved to the right 3. It's vertical, so it's x equals +3. And that's it, you're done there. Find the inverse. So we're going to go ahead and find the inverse now. So again, switch your x and y. So I'm going to go ahead and say x equals negative log base 2 of y minus 3. So again, I just took the original equation and switched the x and y's. Now I need to solve for y. So I need to isolate the log. So the first thing I'm going to go ahead and do is divide everything by -1 so this -1 can cancel. So I'm going to have negative x equals log base 2 of y minus 3. Now I can go ahead and get out of this log form. So in order to do that, my base is 2 to the negative x equals y minus 3. And then my next step, because I want to get y alone, is because it says -3, I'm going to add 3 to both sides. So it's going to say 2 to the negative x plus 3 is equal to y. Oops. And that is my inverse, which of course is exponential. So the domain and range of the inverses, I'm going to stop and have you write these since we've done a few of these. All right, welcome back. So the domain should be matching up with the range of the original one, and the range of the inverse matches up with the domain, and you're done. There's just no work to show for that. All right, last thing we're going to go ahead and take a look at is this example 3 here, describing. So we're going to look at this and we're going to describe what is going on here. We're not going to actually graph them. We're just going to go ahead and see what's going on. And it's kind of to review, because if you have a negative sign on the inside, you need to know where are you reflecting. That reflects over the y-axis. Yes, it multiplies all your x's by -1, but it reflects over the y-axis. If it's on the outside here, it reflects over the x-axis. Do not confuse those. Part C, I'm going to say go ahead and stop. And I'd like you to go ahead and answer how it's going to move. All right, welcome back. Because the -1 is inside, that means it's going to go right 1. Don't worry about D. Okay, if we look at E, the +1 is on the outside of the function, so it's going to go up 1. For this next one, it might be easier if you look at it a little bit differently. Imagine this one is saying y equals negative log base 4 of x plus 1. Because a lot of times people like to see the log first. And when you do that, you're going to notice there's 2 translations here. There's a negative and there's a +1. Or you can notice it here and here, but either way, there's 2 translations. So you're going to go ahead and have to notice that the negative sign is on the outside, so you're going to reflect over the x-axis. And then because of the +1 on the outside, you're also going up 1. So that's 2 things. And we're not going to do this one because we're not going to do anything that crazy. All right, so that is it for the entire unit. You should be able to graph exponentials, you should be able to graph logs, and we'll do some more practice in class.